Hello students, in previous video we have seen error and their types and some examples. In this video we are going to see more examples on error. Let us take first example. Let x is equal to 3.1416 and b the actual value of the number and x1 is equal to 3.14159, be the approximated value of pi of the number pi. Find error, absolute error, absolute error, relative error, and percentage error. Here what we have given, x is equal to 3.1416 be the actual value of the number and x1 is the approximated value of number pi. Then we have to find error, absolute error, relative error and percentage error. Here x is equal to 3.1416 and x1 is equal to 3.14159. The error is, first we have to find error. Error is, it is denoted by capital E, which is equal to x minus x1, that is actual value minus approximated value. What is actual value? 3.1416 minus x1 is 3.14159, which is equal to 0.0001. Therefore the absolute error is, it is denoted by EA and it is given by absolute value of E, that is mod x minus x1, which is equal to modulus of 0.0001, which is equal to 0.0001. Next, what we have to find? Relative error. Therefore relative error is, what is relative error? It is denoted by ER and it is given by mod x minus x1 upon mod x, which is equal to mod x minus x1 is nothing but 0.0001 upon mod x, modulus value of 3.1416. After calculating this, we get 0.00031831. Next, the percentage error is, it is denoted by EP, which is equal to 100 into ER, which is equal to 100 into 0.00031831, which is equal to 0.0031831%. Let us take second example. find evaluate the sum s is equals to root of 3 plus root of 5 plus root of 7 to 4 significant digits and find its absolute error and relative error. See here, in this problem we have to evaluate this sum, and next we have to evaluate this sum to 4 significant digits or 4 significant figures and find its absolute error and relative error. Here what we have given, s is equals to root of 3 plus root of 5 plus root of 7. Root of 3 is equals to 1.732. Root of 5 is equals to 2.236 and root of 7 2.646. Calculate these values on calculator. Hence, add these three numbers, we get s is equals to 1.732 plus 2.236 plus 2.646, which is equals to 6.614. Absolute error is EA is equals to, we have to find absolute error in these three numbers. Absolute error in, see here, this first number is rounded to 3 decimal places, therefore absolute error in this number is 1/2 into 10 raised to minus 3, which is equals to 0.5 into 10 raised to minus 3, which is equals to 0.005. Plus second number is also rounded to 3 decimal places, therefore absolute error in this number is 0.0005. Third number is also rounded to 3 decimal places, therefore absolute error in this number is also 0.005, and total absolute error is 0.0015. See here, this number significant figure or significant digit for this number is 2, therefore sum is rounded to 3 decimal places. Hence, total absolute error shows that the sum is correct to 3 significant figures or digits only. Hence, we take s is equals to 6.61. The relative error is it is denoted by ER, which is equals to EA upon mod X, which is equals to, what is EA is 0.015 upon mod X is nothing but here is S, 6.614. After calculating this, we get 0.002, and the percentage error is, it is denoted by EP, which is equals to 100 into ER. Sorry, here R is small. 0.002 into 100, which is equals to 0.02%. See here, in this problem we have to calculate this number to 4 significant digits and find its absolute error. See here, what we have given, S is equals to root of 3 plus root of 5 plus root of 7. Root of 3 is equals to 1.732, root of 5 is equals to 2.236, and root of 7 is equals to 2.646. Here S is addition of these three numbers, therefore S is addition of these three numbers, which is equals to 6.614. Absolute error, here we have to calculate total absolute error. Total absolute error is, see here, this number is rounded to 3 decimal places, therefore total absolute error in this number is 0.005. Similarly for this number, hence total absolute error is 0.0015. Hence see here, this number is rounded to 2 significant figures, therefore sum is rounded to 1, therefore sum is rounded to, therefore the sum is rounded to 1 digit more than this number, therefore sum is rounded to 3 significant figures only. Hence we take, that is, we round off this number to 3 significant figures, that is 6.61. Relative error is ER is equals to EA upon mod X, which is equals to 0.0015 upon mod 6.614 is equals to 0.002, and percentage error is EP is equals to 100 into ER, which is equals to 0.02%. Let us take third example. Two numbers are given as 2.5 and 48.289, both of which being correct to the significant figure given, then find their product. Here what we have given, two numbers 2.5 and 48.289, both of which being correct to the significant figure given, then we have to find their product. See here, what numbers you have given? 2.5 and 48.289. So here 2.5 is rounded to 1 decimal places. Therefore, absolute error for this number EA is equals to 1 by 2 into 10 raised to minus 1, which is equals to 0.5. See here, this number is rounded to 3 decimal places. Therefore, absolute error in this number is 1 by 2 into 10 raised to minus 3, which is equals to 0.5 into 10 raised to minus 3, which is equals to 0.005. Obviously, 0.5 is greater than 0.005. Therefore, 2.5 is the number with greatest absolute error. Hence, we can say that here 2.5 is the one with greatest absolute error. Is 0.05. Sorry, here 0.05. Therefore, we round off the second number. 48.289, one digit more than this number. See here, significant for this number is 2. Therefore, we round off this number is more than one digit. That is, we round off this number to 3 significant figures. That is 48.3. See here, we have to round off this number to 3 significant figures, that is up to 2. After 2, we discard all the digits, okay, but after 2, this number is 8, which is greater than 5, therefore we add 1 in 2, that round off number becomes 48.3. Therefore, the required product is given by P is equal to 48.3 into 2.5, which is equal to 1.2 into 10 raised to 2. In the product, we retain only 2 significant digits since one of the given number one of the given number 2.5 contains only 2 significant figures. See here, what we have given? 2 numbers, 2.5 and 48.289. In this number, 2.5 is one with the greatest absolute error. So we round off the second number to 3 significant figures, that is 48.3. The required product is multiplication of these two numbers, 48.3 into 2.5, which is equals to 120.75. But we require this number to two significant figures. For this purpose, we discard this term, and 120 can be written as 1.2 into 10 square. Let us take some remarks. First one is absolute error. EA. Students, remember that we can denote absolute error by EA or E capital A. Don't confuse. EA in the product of two numbers x1 and x2 is, it is denoted by EA, x2 into EA1 plus x1 into EA square, where EA1 is absolute error in x1 and EA2 is absolute error in x2. Okay, and second remark is absolute error EA in the question x1 upon x2 is EA is equals to x1 upon x2 minus EA1 upon x1 minus EA2 upon x2. Similarly here, EA1 is absolute error in x1 and EA2 is nothing but absolute error in x2. See here, what is first remark? Absolute error EA in product of two numbers x1 and x2 is EA is equals to x2 into EA1 plus x1 into EA square, that is EA2. EA1 is nothing but absolute error in x1 and EA2 is absolute error in x2. And second remark is absolute error EA in question x1 upon x2 is EA is equals to x1 upon x2 minus EA1 upon x1 minus EA2 upon x2. Let us take next example. Example number 4. Two numbers 4.536 and 1.32, both of which being correct to the significant figure. Find the absolute error. In the product of numbers. Let's see here, we have given two numbers and we have to find absolute error in the product of these numbers. Let x1 is equals to 4.536 and x2 is equals to 1.32. Therefore, EA1, that is absolute error in x1, is 0.5 into 10 raised to minus 3. See, this number is rounded to 3 significant figures, which is equals to 0.005. And EA2, that is absolute error in x2. This number is rounded to 2 significant figures. Therefore, absolute error in x2 is 0.5 into 10 raised to minus 6, which is nothing but 0.05. Therefore, absolute error in the product. We have just seen remark that EA is equals to x2 into EA1 plus x1 into EA2. Just put the values of x1, x2, EA1 and EA square and add them. What is the value of x2? It is 1.32. What is the value of EA1? It is 0.005 plus what is x1? 4.536 into EA2, which is 0.05, which is equals to take multiplication of these two numbers, we get 0.0066 plus 0.02268, which is equals to 0.02334. This is the absolute error in the product of x1 and x2. For this purpose, we have to remember this formula. Let us take fifth example. If x1 is equals to 5.647, x2 is equals to 2.52, both x1 and x2 be correct to the digits both given, find the question Q and relative error in the result Here we have given two numbers x1 and x2. We have to find question and relative error in the result. We have already given x1. x1 is 5.647 and x2 is 2.52. Therefore EA1 means absolute error in x1. This number is rounded to 3 decimal places. Therefore absolute error in this number is 0.5, that is 1 by 2 into 10 raised to minus 3, which is equals to 0.005. Then absolute error in x2, EA2 is equals to 0.5 into, this number is rounded to 2 decimal places, 1, 2. Therefore EA2 is equals to 0.5 into 10 square, which is equals to 0.05. Absolute error is given by, what is the formula? We have seen in remark, EA is equals to x1 upon x2 into EA1 upon x1 minus EA2 upon x2, which is equal to, what is x1? x1 is 5.647 upon x2, 2.52 into EA1, that is 0.005 upon 5.647 minus EA2 is 0.005 upon 2.52, which is equals to, this quotient is 2.2408. Calculate this on calculator, we get 0.00008 minus 0.001984, which is equals to 2.2408 into minus this subtraction is minus 0.001976. This subtraction is minus 0.001976. See here, this is Q, that is quotient. Q is equals to 2.24. We round off this number to 3 significant figures, because in these two numbers, this number is rounded to 3 significant figures, and the relative error is, this 1976, or if we rounded this number to one significant figure, we get 0.02. Okay, we will stop here. In next video we will see bisection method. Thank you.